For centuries, humanity believed the gas giants of our solar system, Jupiter and Saturn, were the ultimate rulers of planetary size. Jupiter, so massive that it could swallow 1,300 Earths inside it, seemed like the limit of what nature could create. But as technology advanced, astronomers began pointing their telescopes farther into the galaxy, searching for worlds beyond our own. What they found shattered every preconception. The universe is filled with planets so massive, so strange, and so alien that Jupiter looks modest by comparison. These giants bend the very definition of what a planet is. Some hover at the edge of becoming stars, while others are inflated like balloons, defying the laws of physics. Some orbit incredibly close to their stars, roasted by radiation, while others drift on the fringes of space, cold and lonely. In this series, we will explore the top 50 largest planets in the universe, each one a cosmic marvel that redefines what it means to be a world. These colossal giants, planets so vast that they blur the line between science fiction and reality. HD 10546b, the giant among giants. HD 10546b stands as one of the most extraordinary planetary discoveries in modern astronomy. Located about 320 light-years away in the constellation Musca, this gas giant is not just enormous, it is still forming. Unlike the mature planets in our solar system, HD 10546b is considered a protoplanet, meaning we are catching it in the act of becoming a planet. This world dwarfs Jupiter, with estimates placing it between 20 to 30 times Jupiter's mass and nearly 7 times its radius. At this scale, astronomers debate whether it should even be called a planet, or if it is closer to a brown dwarf, a failed star that never ignited nuclear fusion. What makes HD 10546b so fascinating is its location within a massive circumstellar disk of dust and gas. This disk is actively feeding the planet, and astronomers using the Very Large Telescope in Chile have been able to directly image its glow, a rare feat in exoplanet science. It is one of the clearest cases we have of witnessing a planet form in real time. The environment around HD 10546b is chaotic, filled with swirling gases, clumps of dust, and possibly even forming moons. Its sheer gravitational power means that if it hosts satellites, some of those moons could be as large as Earth or Mars. Imagine a mini solar system revolving around a single planet. HD 10546b is more than just a massive planet. It's a laboratory for cosmic creation, showing us how worlds are born and evolve. If Jupiter is the king of our solar system, HD 10546b is an emperor among the stars. Dennis PJ 082303.1 491201b, the borderline Titan, with a mass between 28 to 36 times that of Jupiter. This colossal body sits directly on the boundary between gas giant and brown dwarf. Located 67 light-years away in the constellation Vela, it is a cosmic heavyweight whose classification sparks debate among astronomers. The planet was discovered during the Deep Near-Infrared Survey, DENIS, which was designed to find faint stars and planetary objects. What researchers stumbled upon was a world so massive that its atmosphere and core conditions rival those found in small stars. Its atmosphere is likely dominated by hydrogen and helium, but at such immense pressures that exotic states of matter may exist, conditions we can barely replicate on Earth. What makes Dennis PJ0823b truly special is that it blurs the categories of cosmic objects. Is it a planet, formed through accretion around a star? Or is it more like a brown dwarf, formed through direct collapse of gas? The truth may be somewhere in between. Regardless of its label, this world demonstrates that the universe does not conform to neat categories. Some planets, like Dennis PJ0823b, exist in the gray areas, reminding us that nature is more complex than our definitions. If Jupiter's immense gravity protects Earth from incoming comets, then a world 30 times larger would be like a cosmic guardian on steroids. ROX 42Bb, the isolated giant. Few planets are as unusual as ROX 42Bb, a massive world orbiting a binary star system 440 light-years away in the Ophiuchus constellation. Estimated to be 9 times the size of Jupiter, it challenges everything we know about planetary orbits. Unlike planets in our solar system, ROX's 42Bb orbits at a staggering distance of 150 AU. That's 5 times farther out than Pluto is from our Sun. To put it in perspective, if it were in our solar system, it would be orbiting in complete darkness, far beyond the Kuiper Belt. Discovered through direct imaging, ROX's 42Bb glows faintly in infrared light, evidence that it is still hot from its formation. Its youth means it is likely still radiating leftover energy, shining faintly as it cools over millions of years. Because of its immense orbit, astronomers suspect it may not have formed through the standard process of planetary accretion, but instead more like a star, collapsing directly from a cloud of gas. Its massive size suggests it could host a system of moons, potentially as large as Mars or even Earth. Yet because it orbits a binary system, those moons would experience constantly shifting skies, 2 stars in the distance, casting strange patterns of light and shadow. ROX's 42Bb shows us that not all planets stay close to their stars. Some, like this isolated giant, live on the far edges of their systems, existing more like lonely wanderers than traditional worlds. WASP-17b, the puffy retrograde giant. If there's one planet that defies expectation, it's WASP-17b. Located about 1,000 light-years away in the constellation Scorpius, this gas giant is not only massive, it is bizarre. Nearly twice the size of Jupiter but only half its mass, WASP-17b has a density so low it would actually float in water. But its inflated size isn't the only strange feature. WASP-17b orbits its star backwards, a retrograde orbit, completely opposite to the star's rotation. This is incredibly rare and suggests a violent history. Astronomers believe that WASP-17b may have been knocked into its current orbit after a colossal gravitational interaction, possibly with another giant planet, or even a close stellar encounter. Its bloated atmosphere stretches tens of thousands of kilometers into space, making it one of the most puffed-up planets ever observed. Intense radiation from its nearby star is thought to heat and expand its gases, while exotic molecules like titanium oxide may form high-altitude hazes. Observations from the Hubble Space Telescope confirmed the presence of a thick atmosphere, perfect for transmission spectroscopy studies. The scale of WASP-17b is so dramatic that if placed in our solar system, it would dominate the night sky, appearing several times larger than the full moon. Its retrograde orbit and extreme puffiness challenge planetary formation models, forcing astronomers to rethink how giant planets evolve. WASP-17b is a reminder that not all giants are stable or predictable. Some are chaotic survivors of cosmic collisions, reshaped into worlds that shouldn't exist, but do. TRES-4b, the balloon planet. If WASP-17b is strange, then TRES-4b pushes the concept even further. Located about 1,400 light-years away in the Hercules constellation, TRES-4b is one of the largest planets ever discovered in terms of radius. It is 1.8 times the size of Jupiter, but with a mass less than Jupiter's, making it the least dense giant planet we know of. Its density is so low that scientists compare it to balsa wood or cork. You could imagine TRES-4b as a giant cosmic balloon, inflated to the point where it barely holds together. This bizarre property comes from its extreme proximity to its host star. Orbiting at just 0.05 AU, barely a fifth of Mercury's distance from the Sun, it is blasted by stellar radiation that heats and expands its atmosphere. Temperatures on TRES-4b can reach 1,300 degrees Celsius, causing exotic chemistry in its atmosphere. Hydrogen and helium dominate, but heavy elements like carbon compounds may also exist in strange forms. Despite its fragility, TRES-4b has survived for millions of years, defying expectations that its atmosphere should have evaporated. What makes TRES-4b particularly fascinating is that it forces astronomers to rethink planetary stability. How can a planet this delicate survive so close to its star? Is there a hidden mechanism replenishing its atmosphere? Some scientists suggest that tidal heating, caused by gravitational interactions, may help keep its atmosphere inflated. TRES-4b is the ultimate balloon world, a fragile but massive planet that shouldn't exist, and yet it does. Its discovery was a landmark in exoplanetary science, reminding us that the cosmos creates worlds stranger than anything we could imagine. Kepler-39b, the borderline behemoth. Kepler-39b, discovered by NASA's Kepler Space Telescope, is one of the most massive planets ever confirmed. With a mass of nearly 20 times that of Jupiter, it stands on the razor's edge between a gas giant and a brown dwarf. Located about 1,700 light-years away in the constellation Cygnus, Kepler-39b blurs the very definition of what a planet can be. Its orbit is tight, only about 0.15 AU from its parent star, which means it's baked under intense stellar radiation. Despite this, Kepler-39b remains surprisingly massive and compact. Unlike the puffed-up balloon worlds such as WASP-17b or TRES-4b, this planet has an unusually high density, suggesting that it may contain a massive core rich in heavy elements. This dense structure has led scientists to question how it formed. Did it build up gradually through accretion, like normal planets, or collapse directly from a gas cloud like a star? Either way, Kepler-39b is an outlier. What makes Kepler-39b fascinating is its possible stellar sibling identity. At nearly 20 Jupiters, it could almost qualify as a star that failed to ignite. If it were just a little more massive, Nuclear fusion would begin in its core, and it would burn faintly as a red dwarf. Instead, it sits forever in between, glowing faintly in infrared as a giant planet that almost, but not quite, became a star. HAT P67b, the super-puffed Titan. If TRAS 4b was a balloon planet, then HAT P67b takes that idea to the extreme. Located about 1,200 light-years away, this exoplanet is a gas giant with a radius nearly twice that of Jupiter, but with a mass only slightly greater than Saturn's. This makes it one of the least dense planets ever found. Imagine a planet so diffuse that its atmosphere is barely bound by gravity. Astronomers describe it as cotton candy in space. Its inflated atmosphere is caused by its proximity to its host star, a hot and luminous subgiant. Bombarded by constant stellar radiation, its gases expand outward until the planet resembles a giant, fragile bubble. HAT P67b orbits so close that its year lasts only about 4.8 Earth days. With such an extreme orbit, tidal forces stretch and distort the planet, further contributing to its strange structure. The atmospheric temperatures reach thousands of degrees, hot enough to strip lighter elements and drive exotic chemical reactions. Despite its fragility, HAT P67b is an astronomer's dream because its vast, extended atmosphere makes it easier to study. Using transmission spectroscopy, scientists can analyze the starlight filtering through its gases, detecting elements like sodium, potassium, and water vapor. HAT P67b may be unstable, but it's an open book for studying alien atmospheres. It is one of the most surreal worlds ever discovered, so large and so light that if you could somehow place it in a giant cosmic ocean, it would float like driftwood. Kepler-12b, the puffy furnace. Kepler-12b is another world that redefines size and density. About 600 parsecs, 2,000 light-years away, this exoplanet is 1.7 times the size of Jupiter, but only about half as massive. That means it is one of the most inflated hot Jupiters ever observed. Its bloated nature is thought to be caused by stellar irradiation. Orbiting extremely close to its host star at only 0.055 AU, Kepler-12b is constantly blasted by energy. Temperatures soar above 1,500 degrees Celsius, expanding its hydrogen and helium atmosphere to extreme levels. But here's the real mystery. Kepler-12b is even puffier than expected, even accounting for the radiation. This has led scientists to believe that additional processes are at work, such as tidal heating from gravitational interactions or delayed cooling of its interior. It's as if the planet has a hidden energy source keeping it inflated. Because of its size, Kepler-12b is a prime candidate for atmospheric studies. Its thick, extended envelope may contain exotic molecules, possibly titanium oxide, vanadium oxide, or even hazes similar to smog on Earth, but on a planetary scale. Its atmosphere is so extended that it could make the planet appear several times larger during transits. Kepler-12b is proof that size alone does not make sense without density. Here we see a world that has stretched itself into near absurd proportions, becoming a glowing furnace of gas orbiting on the edge of stability. CoRoT 3b, the monster planet. CoRoT 3b is not just large, it is monstrous. Discovered by the French CoRoT space telescope, this planet is an absolute heavyweight, tipping the scales at an incredible 22 times the mass of Jupiter. Located 680 light-years away, Coro T3b is so massive that many astronomers hesitate to call it a planet at all. Its density is extreme, far greater than Jupiter's, making it one of the most compact giant planets ever found. In fact, Coro T3b is more like a brown dwarf than a traditional planet. It orbits extremely close to its star, just 0.057 AU away, with a year that lasts only about 4 Earth days. Because of its mass and size, Coro T3b is considered a benchmark object in the study of planetary formation. It forces scientists to ask, when does a planet stop being a planet? The International Astronomical Union has no clear cutoff, but Coro T3b sits right at the edge. If placed in our solar system, Coro T3b would completely dominate gravitationally, potentially destabilizing the orbits of smaller planets. Its atmosphere, if it exists at all in a stable form, would be crushed under immense pressures. We are talking about conditions so extreme that hydrogen could exist in metallic states, conducting electricity like a metal. Coro T3b is less of a world and more of a cosmic giant, a reminder that the line between planets and stars is razor thin. HAT P32b, the swollen giant. HAT P32b, discovered by the Hungarian Automated Telescope Network, is another example of a superinflated hot Jupiter. Located about 950 light-years away, this gas giant is nearly 2.0 times the size of Jupiter, but has less than a third of its mass. It orbits extremely close to its star, a bright F-type dwarf, completing a full revolution in just 2.2 Earth days. That means it is locked in a gravitational embrace, with extreme tidal forces shaping its atmosphere. Surface temperatures likely exceed 1800 degrees Celsius, causing molecules to break apart and recombine in exotic chemical dances. The planet's inflated nature is so extreme that it challenges every planetary model. Like Tries 4b, it is among the least dense planets known, with a density barely greater than styrofoam. Its enormous size makes it easier for telescopes like Hubble and the upcoming James Webb Space Telescope to probe its atmosphere, searching for signatures of water vapor, methane, or even exotic clouds of silicates and metals. What makes HAT P32b particularly intriguing is its chaotic environment. Its inflated atmosphere may extend far beyond its Roche lobe, the region where a planet's gravity dominates. This means HAT P32b could literally be leaking into space, its gases stripped away by stellar winds. Despite this instability, it endures, swollen to absurd proportions, defying every rule of planetary structure. Kepler 39b, a superJupiter on the edge of planetary limits. Orbiting a star about 1700s away in the constellation Cygnus, Kepler 39b, also known as KOI 423b, is a fascinating world because it blurs the line between a planet and a brown dwarf. With a mass of around 20 times that of Jupiter and a radius nearly 1.2 times larger, Kepler 39b challenges our definitions of what a planet can be. Kepler 39b is classified as a superJupiter, but its sheer size and density raise questions about whether it should be considered a planet at all. Typically, the upper mass limit for planets is about 13 Jupiters. Beyond this, the object can begin nuclear fusion of deuterium, a hallmark of brown dwarfs. Yet Kepler 39b sits uncomfortably in this gray area. It doesn't quite have enough evidence of fusion, but but it is far too massive to resemble ordinary gas giants. Adding to the intrigue is its highly eccentric orbit, meaning it doesn't move in a neat circle around its host star, but instead follows a stretched-out path. This kind of orbit suggests a turbulent past, perhaps involving gravitational interactions with another planet or star that forced it into its current trajectory. The result is that Kepler-39b experiences extreme changes in temperature as it swings closer and farther away from its star, creating violent atmospheric dynamics. For astronomers, Kepler-39b is important because it helps refine the boundary between planets and stars. If it is a planet, it's among the most massive ever discovered. If it's a failed star, it reveals much about the transition point between stellar and planetary formation. Either way, it is a rare cosmic heavyweight, demonstrating that nature doesn't always follow neat categories. In the bigger picture, Kepler-39b reminds us that our definitions of planet are still evolving. Just as Pluto's reclassification forced us to rethink the solar system, giants like Kepler-39b are forcing us to confront the question, where does a planet end and a star begin? WASP-17b, the puffy balloon planet. Discovered by the Wide-Angle Search for Planets (WASP) project, WASP-17b is unlike any world we've ever seen. Located about 1,000 light-years away in the constellation Scorpius, it is notable not just for its immense size, nearly twice the radius of Jupiter, but also for its incredibly low density. If you could somehow scoop it up and place it in a giant ocean, it would float like a cork on water. This strange puffiness is due to its close orbit around its star. WASP-17b circles its sun in just 3.7 days, placing it firmly in the category of hot Jupiters. The intense heat from its nearby star causes the planet's atmosphere to expand dramatically, creating a world that looks more like an inflated balloon than a dense gas giant. Scientists estimate its density to be less than that of styrofoam, making it one of the least dense planets ever discovered. Even more fascinating, WASP-17b orbits in the opposite direction of its star's rotation, a phenomenon known as a retrograde orbit. This is extremely rare and suggests that the planet may have undergone a chaotic past, possibly colliding with or being gravitationally disturbed by another massive body. This violent history likely contributed to its strange orientation and unusual atmosphere. The discovery of WASP-17b provides astronomers with a natural laboratory to study how extreme heat affects planetary atmospheres. Observations have already detected traces of water vapor, carbon dioxide, and sodium in its atmosphere, shedding light on chemical processes that would be impossible to replicate on Earth. WASP-17b proves that not all giant planets are dense and compact like Jupiter. Some can be bloated and fragile, like cosmic balloons drifting around their stars. Its existence reminds us that the universe is endlessly creative, producing worlds that defy our imagination and push the boundaries of planetary science. Kepler-7b, the reflective giant, located about 3,200 light-years away. Kepler-7b is famous for its remarkable brightness and reflectivity. This gas giant, roughly 1.5 times the radius of Jupiter, but less than half its mass, has an extraordinarily reflective atmosphere, making it one of the shiniest planets ever observed. Unlike most hot Jupiters, Kepler 7b reflects a large portion of the starlight it receives. Scientists believe this is because its atmosphere is filled with high-altitude clouds, likely made of silicates, materials that on Earth are found in sand and rock. These clouds act like mirrors, bouncing starlight back into space and giving the planet its dazzling brightness. Another intriguing feature is Kepler 7b's low density, similar to WASP 17b. Despite its large size, its mass is so small that it is less dense than water. This combination of bloated size and reflective clouds creates a planet that appears ghostly white in telescope images, shining against the blackness of space. The Kepler mission, which discovered this planet, was able to create one of the first cloud maps of an exoplanet thanks to Kepler 7b. By observing subtle variations in brightness as the planet orbited its star, astronomers were able to infer the distribution of clouds across its atmosphere. This was a groundbreaking achievement, showing that even planets light years away can be studied in remarkable detail. Kepler 7b isn't just another large exoplanet. It's a cosmic mirror, teaching us how light interacts with alien atmospheres. It stands as proof that beauty exists on a planetary scale, with gleaming worlds shining brightly in the darkness of the cosmos. CoRoT T3b, the heavyweight champion. When it comes to sheer mass, few planets compare to CoRoT T3b. Discovered by the French-led CoRoT space mission, this giant boasts a mass of about 22 times that of Jupiter, placing it on the razor's edge between a planet and a brown dwarf. Despite its enormous mass, CoRoT T3b has a radius only slightly larger than Jupiter's. This means it is incredibly dense, so dense, in fact, that a cubic centimeter of its material would weigh nearly twice as much as lead on Earth. It is one of the densest planets ever measured, earning it the nickname of a super heavyweight planet. CoRoT T3b orbits its star in just 4 days, placing it extremely close and exposing it to intense radiation. However, unlike bloated hot Jupiters such as WASP 17b, CoRoT T3b has resisted inflation because its massive gravity holds its atmosphere tightly bound. The planet occupies a critical place in planetary science because it sits right on the borderline of classification. Some astronomers argue that with its mass, it should be considered a brown dwarf, while others point out that it formed in a disk around its star, which is characteristic of planets. This debate makes CoRoT T3b a case study for understanding the gray area between planetary and stellar objects. For researchers, CoRoT T3b is a natural laboratory for extreme physics. Studying such dense, massive worlds helps us understand not just planets, but the broader processes of star and planet formation. In the cosmic boxing ring, CoRoT T3b is the reigning champion of planetary mass and density, showing us just how diverse planets can truly be. HD 189733b, the planet where it rains glass. HD 189733b is one of the most terrifying yet beautiful worlds ever discovered. A deep blue gas giant where molten glass rains sideways through winds that scream across the planet at more than 7,000 km/h. Located about 64 light-years away in the constellation Vulpecula, this planet has become an icon of extreme weather in the cosmos. Roughly the size of Jupiter but slightly heavier, HD 189733b orbits its parent star at a distance so small that its year lasts only 2.2 Earth days. The planet is tidally locked. One side forever faces the star, while the other remains in eternal darkness. The dayside temperature exceeds 1,000 degrees Celsius, turning metals and silicates into vapor. On the night side, these vapors cool and condense into tiny shards of glass that are whipped around the planet by supersonic winds. Its mesmerizing sapphire blue color once led astronomers to think it might be a calm ocean world. But observations from the Hubble Space Telescope revealed the truth. That deep blue isn't water. It's the reflection of silicate particles high in the atmosphere. These particles scatter blue light, giving the planet a deceptive, jewel-like glow that hides a deadly environment beneath. Scientists believe the extreme winds are driven by the massive temperature difference between the blazing day side and the freezing night side. The constant tug-of-war between these regions fuels a never-ending storm system, one that could easily shred anything caught within it. HD 189733b is a vivid reminder of how alien other worlds can be. Its sparkling blue clouds and glass storms create a landscape that's both dazzling and deadly, a true Beauty and the Beast planet. To look at it is to glimpse a storm so violent and unearthly that even the wildest weather on Earth feels calm by comparison. Kepler 70b, the planet that survived a star's death. Kepler 70b is one of the most extreme and tragic worlds ever found, a planet that quite literally survived the death of its own star. Located around 4,000 light-years away in the constellation Cygnus, this scorched world orbits what remains of its parent star, a hot subdwarf known as Kepler 70, the burnt-out core of a once massive sun-like star. This planet's story begins billions of years ago, when its star began to die. As the star aged, it expanded into a red giant, growing so large that it engulfed its inner planets, including Kepler 70b. Normally, that would mean total destruction, but somehow Kepler 70b survived the inferno. It now orbits incredibly close to the stellar remnant, completing a full revolution in just 5.8 hours, one of the shortest orbits ever recorded. At that proximity, the surface temperature is estimated at 7,200 degrees Celsius, hotter than many stars. The planet's rocky crust has likely melted into a global ocean of magma, constantly blasted by radiation from the exposed stellar core. It's smaller than Earth, about 0.8 times Earth's radius, yet far denser, possibly a stripped remnant of a much larger planet whose atmosphere and outer layers were vaporized during the red giant phase. Astronomers believe Kepler 70b was once part of a multi-planet system. Some evidence suggests another surviving planet, Kepler 70c, orbits nearby in a similarly tight path, both moving in near-perfect resonance, relics of a solar system that was nearly destroyed. Kepler 70b stands as a cosmic survivor, a planet that endured its star's death and now circles its glowing corpse in a blistering dance of fire. It's a haunting reminder of what might await our own solar system billions of years from now, when the sun becomes a red giant and the inner worlds face their own fiery end. HD 29458b, Osiris, the planet that's evaporating away. Known more commonly by its nickname Osiris, HD 29458b is one of the most famous exoplanets ever discovered and for good reason. Located about 150 light-years away in the constellation Pegasus, Osiris was the first exoplanet ever observed to transit its star, and it has become a cornerstone in exoplanetary science. What makes Osiris so extraordinary is that it is literally evaporating before our eyes. This hot Jupiter, orbiting extremely close to its star in just 3.5 days, is being blasted by intense stellar radiation that heats its upper atmosphere to thousands of degrees. As a result, hydrogen, carbon, and oxygen atoms are escaping into space, forming a gigantic tail of gas that trails behind the planet like a comet. This planetary death has made Osiris one of the most important exoplanets for studying atmospheric escape. Observations from the Hubble Space Telescope showed a massive cloud of hydrogen surrounding the planet, stretching tens of thousands of kilometers into space. This was the first time scientists confirmed that planets could lose their atmospheres due to stellar radiation, a process that may have shaped even our own solar system in its early days. Another fascinating aspect of Osiris is its inflated size. Like Kepler-12b, it is much larger than expected for its mass, measuring about 1.4 times Jupiter's radius. Its puffiness, combined with the atmospheric escape, makes it one of the most dramatic examples of how stellar environments can reshape planets. For scientists, Osiris provides a direct look at the future of some exoplanets. Many hot Jupiters may be doomed to evaporate completely, leaving behind only rocky cores or disappearing entirely. Osiris is not just a planet. It's a cosmic warning about the destructive power of stars and the fragility of planetary atmospheres. This giant, slowly dissolving world is both tragic and beautiful, a reminder that planets, like living things, can wither under the relentless heat of their suns. TRES-4b, the largest planet ever discovered so far. If there is one planet that embodies the concept of too big to be true, it is TRES-4b. Located about 1,400 light-years away in the constellation Hercules, TRES-4b holds the title of the largest exoplanet ever found, with a radius nearly 1.8 times that of Jupiter. Despite its immense size, TRES-4b is incredibly light. Its density is so low that it is often compared to balsa wood or even styrofoam. Scientists estimate that TRES-4b is less dense than water, meaning if there were an ocean big enough, it would float. This bizarre combination of size and fluffiness makes it one of the most puzzling planets in the universe. TRES-4b orbits very close to its star, completing a year in just 3.5 days, which explains some of its inflation. But its extreme size is still a mystery. Current models of planetary formation cannot easily explain how a planet can expand so dramatically without losing stability. Some theories suggest internal heating mechanisms, such as tidal heating, while others point to unusual atmospheric compositions that allow heat to linger. Its atmosphere is believed to contain exotic chemicals, possibly including titanium oxide, which absorbs stellar radiation and contributes to the planet's expanded size. The result is a swollen, overheated gas giant that seems to defy the normal rules of planetary physics. For astronomers, TRES-4b is both a challenge and a treasure. By studying it, they hope to better understand the balance between gravity, heat, and atmospheric dynamics that govern giant planets. In many ways, TRES-4b shows us the upper limit of how big a planet can get before physics begins to push back. This world is a reminder that the universe doesn't always follow our expectations. Sometimes it produces balloon-like titans, larger than theory ever imagined. Kepler-51's superpuff planets, cotton candy worlds. In 2014, the Kepler Space Telescope discovered a truly bizarre planetary system around a star about 2,600 light-years away. The system, known as Kepler-51, hosts several planets that are so incredibly low in density that astronomers nicknamed them cotton candy planets. Among these, Kepler-51b and Kepler-51d are especially remarkable. Despite having sizes comparable to Jupiter, their masses are tiny, only a few times that of Earth. This means their densities are about 0.1 grams per cubic centimeter, which is lighter than cotton candy. How can such fluffy planets exist? Scientists believe these superpuffs have enormous, extended hydrogen-helium atmospheres swollen by the heat of their star. Their atmospheres likely contain thick hazes that make them appear even puffier. But this extreme puffiness is temporary. Over time, these planets may lose much of their gas, shrinking down into smaller, denser worlds. Studying the Kepler-51 system gives astronomers a glimpse of planetary adolescence. These planets are still young, barely a few 100 million years old, and their oversized atmospheres are a natural part of early planetary evolution. In many ways, they are cosmic teenagers, awkward, unstable, and still growing into their final forms. Kepler-51's superpuffs challenge our understanding of planet formation, especially for gas giants. They show that not all planets evolve in the same way, and that some may begin their lives as enormous, airy worlds before contracting into something more familiar. The cotton candy planets remind us that the universe has a sense of humor, sometimes producing giant planets as fluffy as carnival treats, floating lightly in the cosmic void. Kepler-13ab, the scorching giant of metal rain. If Kepler-12b is the balloon world and Kepler-51b is cotton candy, then Kepler-13ab is the world of fire and metal. Orbiting a star about 1730 light-years away, this massive hot Jupiter is one of the hottest exoplanets ever discovered, with temperatures exceeding 2,700 degrees Celsius. What makes Kepler-13ab so terrifying is that it likely experiences titanium rain. At such extreme temperatures, metals like titanium oxide can remain vaporized in the atmosphere. But on the cooler night side of the planet, these vapors condense into metallic droplets that rain down from the skies. Imagine a world where the weather forecast includes showers of molten metal, a truly alien climate. Kepler-13ab is also unusual because of its locked orbit. Like many close-in exoplanets, one side always faces its star while the other remains in permanent night. This creates an extreme temperature difference that drives powerful winds across the atmosphere, likely exceeding thousands of kilometers per hour. Adding to the drama is Kepler-13ab's enormous gravity. It is more massive than Jupiter, and its gravity actually pulls its atmosphere closer to the planet's surface, creating a very different atmospheric structure than most hot Jupiters. Observations by the Hubble and Spitzer space telescopes have revealed complex dynamics in its clouds, offering scientists a chance to study how extreme heat interacts with massive planetary atmospheres. For astronomers, Kepler 13ab is a perfect example of a hell world, a planet so hostile and extreme that it seems almost designed to show us the violent side of the cosmos. It proves that planets can be as diverse as stars, with climates ranging from cotton candy fluff to storms of molten titanium. HD 189733b, the Blue Storm Planet. At first glance, HD 189733b looks like a beautiful Earth-like world. Astronomers discovered that it appears deep blue when observed from space, much like our oceans. But don't be fooled, this planet is no paradise. In fact, it is one of the most violent and dangerous worlds ever discovered. HD 189733b is a hot Jupiter located about 64 light-years away, slightly larger than Jupiter. Its beautiful blue color doesn't come from oceans or water, but from silicate particles in its atmosphere that scatter blue light. These same particles are part of an atmosphere where glass-like rain falls sideways, driven by winds reaching speeds of 8,700 kilometers per hour. Imagine razor-sharp shards of glass raining across a planet at hurricane-force winds that never end. This is daily weather on HD 189733b. Temperatures on the planet's day side reach over 1,000 degrees Celsius, and like many hot Jupiters, it is tidally locked. One side always faces its star, while the other remains in eternal night. The sharp temperature contrast creates violent jet streams and storms that encircle the planet. What makes HD 189733b particularly fascinating is how much detail astronomers have been able to uncover. It was one of the first exoplanets to have its atmosphere directly measured, and its color was confirmed through the Hubble Space Telescope. This opened a new chapter in exoplanet science, showing that we can not only detect distant planets, but also begin to study their skies, their weather, and their colors. HD 189733b reminds us that appearances can be deceiving. From far away, it may look like Earth, but up close, it is an alien nightmare, an eternal storm world of glass and fire. GJ 1214b, the Water World. GJ 1214b, located just 40 light-years from Earth, has been called the Water World because it may be one of the most water-rich planets ever discovered. With a size about 2.7 times that of Earth and a mass roughly 7 times greater, this planet falls into the category of a super-Earth, or mini-Neptune. What makes GJ 1214b so remarkable is the strong evidence suggesting it is composed largely of water, possibly up to 75% of its mass. If true, its surface may not be rocky or gaseous like most planets, but instead covered in deep global oceans, potentially hundreds of kilometers deep. These oceans would make Earth's deepest trenches look shallow in comparison. The atmosphere of GJ 1214b is likely thick and steamy, creating a water vapor greenhouse effect. Surface temperatures could reach 200 to 300 degrees Celsius, hot enough to prevent liquid oceans, but capable of forming strange states of water, such as hot ice and superfluid water, under extreme pressure. These exotic forms of water do not exist naturally on Earth, but they are thought to be stable on worlds like GJ 1214b. Its discovery marked one of the first strong indications that exoplanets could be fundamentally different from those in our solar system. While Earth has land, sea, and sky, GJ-1214b might be a true ocean planet, a world where endless seas stretch from horizon to horizon, with no land at all. The study of this planet not only excites scientists searching for exotic environments, but also raises questions about habitability. Could microbial life exist in such extreme oceans? Could future technologies allow us to explore beneath its dense clouds? GJ-1214b is a world that may hold answers to what water-based planets can become across the universe. Kepler-10c, the Mega-Earth. Kepler-10c is one of the most astonishing rocky worlds ever discovered, so massive that astronomers nicknamed it the Mega-Earth. Located about 560 light-years away in the constellation Draco, this planet orbits a sun-like star in the Kepler-10 system, alongside another smaller rocky planet, Kepler-10b. At first, scientists thought Kepler-10c was a typical mini-Neptune, a planet with a thick atmosphere of gas surrounding a small rocky core. But when its mass was later measured, the results shocked everyone. The planet turned out to be 17 times heavier than Earth and 2.3 times larger in diameter, yet still made almost entirely of rock and solid materials. That makes it one of the densest planets ever found, far heavier than any other known rocky world. Its surface gravity would be over 3 times stronger than Earth's, meaning a person weighing 70 kilograms here would feel like they weigh more than 200 kilograms there. The intense pressure and heat beneath its crust likely form layers of exotic minerals and possibly even metallic oceans deep underground. Kepler-10c orbits its star every 45 Earth days, meaning it's much closer to its sun than Mercury is to ours. Surface temperatures could exceed 200 degrees Celsius, far too hot for life as we know it. However, its sheer size and solid nature defied previous assumptions that large planets must always become gas giants. This discovery had a major impact on planetary science. It showed that massive rocky planets can form and survive, even in the harsh, early universe. Kepler-10c likely formed billions of years ago when heavy elements were still rare, proving that rocky planets existed much earlier than scientists believed possible. Kepler-10c redefined the boundaries between Earth-like worlds and gas giants. It's not just a super-Earth, it's a mega-Earth, a colossal testament to how powerful and diverse planetary formation can be across the cosmos. Kepler-22b, the first habitable zone. Super-Earth Kepler-22b is one of the most famous exoplanets because it was the first discovered planet orbiting within the habitable zone of its star, a region where liquid water could potentially exist. Located about 600 light-years away, Kepler-22b is about 2.4 times the size of Earth, placing it in the category of a super-Earth. Its star, Kepler-22, is very similar to our Sun, and the planet orbits at just the right distance to allow moderate temperatures. This made it an early candidate for possible habitability, igniting worldwide excitement when it was announced. Scientists estimate its average surface temperature could be around 22 degrees Celsius if it has an atmosphere like Earth's. However, Kepler-22b's true nature is still a mystery. It may be a rocky world with oceans, or it could be a mini Neptune with a thick gaseous envelope. Either way, its discovery confirmed that Earth-sized planets do exist in habitable zones, strengthening the possibility that life-friendly worlds are common. What made Kepler-22b historic is how it changed the search for exoplanets. Before its discovery, most known exoplanets were gas giants. Kepler-22b proved we could find smaller, Earth-like worlds around distant stars, and it inspired missions like TESS and JWST to search for more. Even if Kepler-22b turns out to be too gaseous for life as we know it, its existence brings us closer to answering one of humanity's greatest questions. Are we alone in the universe? TRES-2b, the darkest planet in the galaxy. If HD 189733b was the stormy blue planet, then TRES-2b is its opposite, a planet so dark it reflects almost no light. Located about 750 light-years away, this gas giant is about the same size as Jupiter, but it reflects less than 1% of the starlight that hits it. That makes TRES-2b blacker than coal, darker than asphalt, and the darkest planet ever observed. Why is it so dark? Scientists believe its atmosphere is composed of light-absorbing chemicals like vaporized sodium, potassium, and titanium oxide. Unlike Jupiter, which has clouds of ammonia crystals that reflect sunlight, TRES-2b's atmosphere lacks reflective clouds, turning it into a near-perfect light trap. Despite its darkness, the planet isn't invisible. At temperatures of nearly 1,000 degrees Celsius, TRES-2b actually glows faintly red, like burning embers in a fire. If you were somehow able to look at it up close, it would appear as a giant black sphere faintly glowing with a sinister red hue. TRES-2b's discovery is scientifically important because it challenged assumptions about exoplanet albedos, reflectivity. It proved that not all gas giants have bright, reflective clouds, and that some planets can exist in a state of near-total darkness. This eerie world reminds us that beauty is not the rule of the cosmos. Sometimes, alien planets can be as dark and foreboding as the deepest shadows of space. PSR B1257 plus 12b, the pulsar planet. PSR B1257 plus 12b is one of the strangest and most haunting planets in the known universe, a world that orbits a dead star. It lies about 2,300 light-years away in the constellation Virgo and circles a pulsar, the collapsed, rapidly spinning core of a massive star that exploded in a supernova. This pulsar rotates hundreds of times per second, releasing intense beams of radiation that sweep across space like a cosmic lighthouse. Discovered in 1992, PSR B1257 plus 12b made history as one of the first confirmed exoplanets ever found. Yet it orbits one of the most violent types of stars imaginable. The planet is roughly half the mass of Earth and sits incredibly close to the pulsar, completing a full orbit every 25 days. Instead of warm sunlight, its skies are constantly bombarded by deadly X-rays and gamma radiation. Any atmosphere it once had was long ago stripped away, leaving behind a scorched, airless surface. The pulsar's extreme gravity and magnetic fields make this system a nightmare for life as we know it. Temperatures would swing between blistering heat and freezing cold, and constant radiation storms would tear through any exposed material. Astronomers sometimes call worlds like this zombie planets, because they orbit the remains of a star that has already died. Despite its bleakness, PSR B1257 plus 12b changed science forever. The tiny variations in the pulsar's radio pulses revealed the presence of planets through timing analysis, an entirely new detection method at the time. This discovery proved that planets could survive even the cataclysmic death of a star, reshaping our understanding of planetary formation and resilience. PSR B1257 plus 12b is not a world of life or light, but a monument to endurance, orbiting a stellar corpse that should have destroyed everything around it. In the silence after a supernova, this lonely planet continues to circle its dead sun, a ghostly reminder that even in death, the universe still creates. HAT P7b, the planet of constant storms. Imagine a world where storms never end, where fierce winds whip across the atmosphere at 7,000 kilometers per hour, faster than a speeding bullet. That is HAT P7b, a massive gas giant about 40% larger than Jupiter, orbiting a star nearly 1,000 light-years away. This planet is what astronomers call a hot Jupiter. Locked in a tidally fixed orbit, one side always faces the star, while the other remains in endless night. The day side is scorched to over 2,500 degrees Celsius, hot enough to vaporize metals, while the night side cools to much lower temperatures. This imbalance drives massive storms as heated gases rush from the star-facing side toward the dark side. But the most extraordinary discovery on HAT P7b is its gemstone weather. Scientists studying its atmosphere found evidence that clouds may form from corundum, the mineral that makes rubies and sapphires. Imagine a sky filled with ruby red and sapphire blue clouds, illuminated by lightning storms, raining down crystal particles. It is a breathtaking but violent alien spectacle. Using the Kepler Space Telescope, astronomers also observed the first ever shifting weather patterns outside our solar system. The reflective cloud cover on HAT P7b appeared to move over time, proving that alien planets can experience dynamic weather similar to, but far more extreme than Earth's storms. This discovery showed us that giant exoplanets are not just oversized spheres of gas. They are living, chaotic worlds where physics, chemistry, and weather interact on unimaginable scales. CoRoT T7b, the Hell Planet. Few planets deserve the title of Hell Planet as much as CoRoT T7b. Located about 480 light-years away, this rocky exoplanet is only about 1.6 times the size of Earth, but its environment is one of the most hostile ever discovered. Orbiting its star at a distance closer than Mercury is to the Sun, CoRoT T7b completes a full orbit in just 20 hours. This extreme proximity makes the planet's surface blazing hot. On the day side, temperatures soar to 2,300 degrees Celsius, hot enough to melt rock into lava. Astronomers believe the planet may have seas of molten rock, with rivers of lava replacing Earth's oceans. On the dark side, however, the temperature plummets to hundreds of degrees below zero. This wild difference creates bizarre conditions. Rock vapor from the day side can condense and rain down as stone snow on the night side. Imagine walking from a fiery lava ocean into a frozen desert of rock snow. CoRoT T7b is a world of extremes. Another remarkable fact is that CoRoT T7b was among the first confirmed rocky exoplanets ever discovered. Until then, most known exoplanets were giant gas worlds. Its discovery marked a turning point, proving that Earth-like rocky planets exist beyond our solar system, though not all are habitable. Coro T7b reminds us that while Earth is a gentle cradle of life, other rocky planets in the cosmos can be deadly furnaces, places where survival is impossible, but scientific discovery thrives. GJ504b, the pink planet. GJ504b stands out as one of the most visually stunning worlds ever discovered, often called the pink planet. It's located about 57 light-years away in the constellation Virgo and orbits a bright sun-like star named GJ504. What makes this planet so extraordinary is not just its size or distance, but its striking rose-colored hue, a rare sight in the known universe. GJ504b is roughly 4 times the mass of Jupiter, yet its orbit is far wider, about 43 times the Earth-Sun distance, or nearly 5 times farther than Jupiter orbits our Sun. This distant orbit means the planet receives much less heat from its star, keeping it relatively cool for a gas giant. Scientists estimate its temperature to be around 225 degrees Celsius, cool enough for its atmosphere to retain vivid colors that hotter planets usually lose. Its pinkish magenta tint likely comes from a mix of chemical compounds in its upper atmosphere, such as methane and clouds made of exotic materials like silicate crystals. Infrared observations by the Subaru telescope in Hawaii revealed this unique coloration, making GJ504b the coldest and most directly imaged exoplanet at the time of its discovery. What's especially fascinating is its youth. GJ504b is estimated to be only 160 million years old, which is very young compared to our 4.5 billion-year-old Jupiter. Because of this, it still radiates leftover heat from its formation, giving it that gentle pink glow instead of the duller tones seen in older gas giants. This planet also challenges current theories of planet formation. Traditional models suggest such massive worlds form close to their stars, yet GJ504b exists in the distant outskirts of its system. Its very presence hints that planets may form and migrate in far more diverse ways than we once imagined. GJ504b is both beautiful and mysterious, a glowing pink jewel adrift in the darkness, reminding us how artistic and unpredictable the universe can be. A planet with a helium atmosphere. While hydrogen dominates the atmospheres of most gas giants, there exists a fascinating subset of exoplanets where helium takes center stage. These planets have lost much of their hydrogen due to a process called atmospheric escape, a gradual peeling away of the lightest gases driven by intense stellar radiation and powerful stellar winds. Over millions of years, hydrogen, being the lightest element, escapes more easily, leaving behind an atmosphere largely composed of helium, the second lightest but much more inert element. Helium atmospheres are remarkable because helium is chemically inert and does not participate in the complex reactions that shape weather on hydrogen-rich planets. This means the planet's weather patterns, cloud chemistry, and thermal properties differ dramatically. Without the colorful storms or thick clouds seen on Jupiter or Saturn, these planets may appear much clearer and calmer, their skies tinted faintly by starlight passing through helium gas. Astronomers detect these rare atmospheres using transmission spectroscopy, which observes how starlight filters through a planet's outer layers during a transit. Helium leaves a distinct absorption mark at 1083 nanometers in the near-infrared range, an unmistakable fingerprint that allows scientists to identify and study these exotic worlds. In some cases, escaping gas has even been observed forming long, faint tails behind the planets, showing just how quickly their atmospheres are being stripped away. One well-known example is WASP 107b, a Neptune-sized exoplanet about 200 light-years from Earth. It orbits so close to its star that its outer layers are constantly evaporating, leaving behind a helium-dominated atmosphere. Planets like this may represent a transitional phase, caught between being a small gas giant and a rocky super-Earth. The loss of hydrogen and the rise of helium mark a late stage in a planet's atmospheric evolution, especially for worlds orbiting close to their stars. Over long timescales, they may continue to lose material until only dense, compact cores remain. Studying these helium-rich planets gives astronomers valuable insight into how planetary atmospheres change and how stars gradually reshape the worlds that orbit them. They are silent witnesses to the slow transformation of planets under the relentless power of starlight. TOI 3757b, the Puffy Giant. TOI 3757b is one of the puffiest and least dense exoplanets ever found. Orbiting a cool red dwarf star about 580 light-years away in the constellation Auriga, it's roughly the same size as Jupiter but far lighter, with a density even lower than Saturn's. In simple terms, it's a giant world that looks massive but is mostly empty inside, like a cosmic balloon. Astronomers discovered TOI 3757b using NASA's TESS telescope, which detects small dips in a star's light when a planet passes in front of it. Further observations revealed that despite its large size, the planet's mass was surprisingly small. Its average density is about 1/3 of Jupiter's, suggesting that most of it is made of hydrogen and helium rather than heavier elements. Scientists believe its puffiness comes from two main factors. First, the planet's star is low in heavy elements, meaning TOI 3757b likely formed with a small, weak core. Without a strong core, its gravity couldn't pull the gases tightly together, allowing the planet's outer layers to expand. Second, it orbits extremely close to its star, completing one revolution every 3.4 Earth days, and constant stellar heat keeps its atmosphere swollen and unstable. Over time, this combination of weak gravity and intense radiation may be slowly stripping away its atmosphere. Some gases might be escaping into space, leaving a faint halo around the planet. In the distant future, TOI 3757b could lose much of its mass and shrink into a dense, smaller remnant. What makes TOI 3757b remarkable is that such large, low-density gas giants are rare around red dwarfs. These stars typically host small, rocky planets, not massive, inflated worlds. Its existence challenges what astronomers thought they knew about how planets form and survive near small stars. In short, TOI 3757b is a strange, delicate world, huge in size but light as air, quietly drifting around its faint star like a fragile balloon in the darkness of space. A diamond planet, carbon-rich world. Among the most stunning theoretical planetary types are diamond planets, worlds formed in stellar nurseries rich in carbon rather than oxygen. In our solar system, oxygen dominates, leading to silicate and oxide minerals that form Earth and other terrestrial planets. But in carbon-rich environments, chemistry flips. Carbon bonds dominate, creating planets where diamond layers and graphite surfaces might be common. Deep beneath the surface, immense pressures, millions of times those on Earth's crust, force carbon atoms into crystalline diamond structures. These vast diamond layers could be tens to hundreds of kilometers thick, encasing a core unlike anything on Earth. On the surface, graphite or diamond dust might coat the landscape, giving these worlds a brilliant shine or a dark, glittering look, depending on surface conditions. These exotic planets challenge traditional geological models. Their tectonics, volcanism, and atmospheric compositions would differ radically from silicate-based planets. Carbon-rich planets could have thick atmospheres rich in methane or other hydrocarbons, with entirely alien weather systems. From a scientific perspective, finding diamond planets helps astronomers understand planetary diversity and the impact of stellar composition on planet formation. For the imagination, these glittering cosmic gems evoke images of whole worlds forged from nature's hardest substance, transforming science fiction into plausible reality. The lava world, a molten planet. Lava worlds are some of the most extreme exoplanets discovered, orbiting perilously close to their parent stars, often completing an orbit in mere days or hours. The immense heat from their stars melts their rocky surfaces into rivers, lakes, and seas of molten rock. Temperatures can soar above 2,000 degrees Celsius, far hotter than volcanic lava on Earth, creating landscapes that glow red and orange from space. These planets are usually tidally locked, meaning one side perpetually faces the star, baking under constant heat, while the other side remains in frigid darkness. The molten day side features rivers of lava flowing endlessly, reshaping the planet's surface continuously, while the night side cools to form jagged solid crusts that eventually break apart as they're pulled toward the hot side. Giant volcanic plumes and rock rains cycle vaporized minerals from the hot side to the cold, where they condense and fall like molten droplets, creating a rock cycle unlike any on Earth. Understanding lava worlds gives astronomers a glimpse into the fiery youth of terrestrial planets and the effects of extreme irradiation and tidal forces. These hellish landscapes are natural laboratories for studying magma physics and volcanic processes under extreme conditions. They also hint at the boundaries of habitability, reminding us how some planets exist in perpetual infernos, far removed from the life-friendly conditions we cherish. A water world without land. Water worlds, or ocean planets, are celestial bodies covered entirely by deep global oceans without any land masses. These planets form far from their stars, where ices dominate and later migrate closer, melting their thick, icy shells into liquid water layers that can be hundreds of kilometers deep. Unlike Earth, where land interrupts ocean currents and supports diverse ecosystems, these water worlds offer an uninterrupted aquatic expanse. Such vast oceans would exert immense pressure at the ocean floor, creating exotic ice phases of water that don't exist naturally on Earth, including super-pressurized ice layers that behave more like solids despite high temperatures. Without continents, nutrient cycling and ecosystem development might differ drastically, potentially limiting the evolution of complex life or shaping entirely alien biospheres. Scientists theorize that life, if it exists, would thrive around deep-sea hydrothermal vents, where geothermal energy provides warmth and nutrients in the absence of sunlight. The thick ocean layers might also insulate the planet's interior, promoting geological activity and even magnetic fields. Water worlds challenge our traditional notions of habitability and life, expanding the habitable zone concept and inviting speculation about alien oceans teeming with life, unseen beneath endless blue horizons. The rogue giant adrift in darkness. Unlike most planets that revolve faithfully around their parent stars, rogue planets are cosmic exiles, celestial wanderers drifting alone through the vast, starless darkness of interstellar space. These planets were likely born within regular solar systems, but were later flung out by violent gravitational interactions, perhaps after a close encounter with another giant planet or a passing star. In this chaos, they lost their suns forever and now roam the galaxy untethered, guided only by the pull of distant stars and the gravity of the Milky Way itself. Among them exist the rogue giants, massive gas worlds often larger than Jupiter, yet cast away into eternal solitude. Without the warmth or light of a nearby star, these giants exist in a permanent night, illuminated only by the faint afterglow of their own internal heat. This dim infrared warmth is the last breath of their birth fire, the lingering energy from when they first condensed out of swirling clouds of gas and dust billions of years ago. Despite the cold emptiness around them, rogue giants are not entirely lifeless. Deep within their thick atmospheres, pressures and temperatures could remain intense, creating dynamic storms, turbulent winds, and glowing auroras sparked by internal magnetism. If these lonely worlds possess moons, as giant planets often do, it's possible that tidal heating or residual radioactive decay could keep subsurface oceans beneath layers of ice in a liquid state. In such hidden geothermal pockets, life could theoretically exist, far from any sunlight. Detecting these planets is one of astronomy's greatest challenges. Since they emit no reflected light, scientists must rely on subtle methods such as gravitational microlensing or infrared telescopes to find them. Yet, even with limited detections, current models suggest that billions of rogue planets might drift unseen across our galaxy, outnumbering the stars themselves. The image of a rogue giant evokes something both eerie and poetic. A colossal, silent wanderer, endlessly journeying through darkness, neither living nor dead. These lonely worlds remind us how violent, unpredictable, and mysterious the universe truly is. And with every discovery of such a drifting planet, astronomers are forced to rethink the boundaries of planetary formation and the resilience of life, even in the coldest corners of the cosmos. Kepler 1658b, the long-lost giant. Kepler 1658b is a gas giant with one of the most unusual discovery stories in astronomy. It was actually the first planet candidate ever detected by NASA's Kepler Space Telescope back in 2009. But scientists couldn't confirm it at the time. For nearly a decade, it remained an unsolved mystery, buried in old data until researchers re-examined the records and finally proved its existence in 2019. That's why it's often called the long-lost planet. Kepler 1658b orbits a bright, evolved star located about 2,600 light-years away. It's roughly the same size as Jupiter, but about 3 times more massive, making it both dense and compact. The planet circles its host star extremely closely, completing a full orbit in just 3.8 Earth days. Because of that proximity, its surface temperature is incredibly high, likely exceeding 1,800 degrees Celsius. Its outer atmosphere is constantly blasted by stellar radiation, causing intense heat and violent atmospheric activity. This close orbit has led astronomers to believe that Kepler 1658b is slowly spiraling inward toward its star. Over time, gravitational interactions between the two bodies, known as tidal decay, are gradually shrinking the planet's orbit. One day, possibly in a few million years, it may be pulled completely into its star and destroyed. The planet's host star is also special. It's a subgiant, a star that has started expanding and brightening as it nears the end of its life. That makes Kepler 1658b an important target for studying how planets behave around aging stars. Observing this system helps scientists understand the future of planets like Mercury or even Earth, when our Sun eventually grows into a red giant. Kepler 1658b is more than just a hot Jupiter. It's a glimpse into a planet's final days. Once forgotten and rediscovered years later, it represents both the persistence of science and the fragile balance that keeps planets alive in the harsh light of their stars. The triple sun planet, a world with 3 stars. Orbiting triple star systems represent some of the most complex and extraordinary worlds known. Unlike our single-star Sun, these planets live under the gravitational influence of 3 suns dancing in intricate orbital ballets. The combined gravitational forces produce highly dynamic environments with variable illumination, temperature swings, and complex orbital stability challenges. On such a planet, the sky could feature 3 suns simultaneously, one setting, one rising, and one high above, creating surreal patterns of light and shadow. Day lengths and night lengths would shift unpredictably as the stars orbit one another, producing a kaleidoscope of dawns and dusks. The intense combined radiation from multiple stars might create harsh climates, while gravitational perturbations could cause tidal heating and orbital eccentricities. Discovering planets in triple star systems expands the search for habitable environments beyond traditional settings. It demonstrates nature's ability to produce stable orbits even in chaotic gravitational fields and challenges astronomers to model planetary climates under multifaceted stellar influence. These exotic worlds stretch the imagination and hint at the diversity of environments where life might arise, adapting to the dazzling, shifting skies of triple-star suns. WASP 193b, the Balloon World. WASP 193b is one of the most extraordinary exoplanets ever found, a world so large and light that scientists compared it to cotton candy. It lies about 1,200 light-years away from Earth and orbits a bright, sun-like star. With a diameter nearly 1.5 times that of Jupiter, but only about 14% of its mass, this planet's density is extremely low. roughly 0.06 grams per cubic centimeter, making it one of the fluffiest planets known. Discovered by the Wide-Angle Search for Planets (WASP) project, this gas giant immediately caught astronomers' attention because it didn't behave like a normal planet. Its massive size and low weight suggest that its outer layers are incredibly expanded, likely due to the intense heat it receives from its star. The planet orbits very close, completing a full revolution in just a few days, and constant stellar radiation keeps its atmosphere swollen and unstable. At such high temperatures, the gases that make up WASP-193b's atmosphere, primarily hydrogen and helium, expand to create a massive low-density envelope. This gives the planet a fluffy, balloon-like appearance and makes it much larger than it would otherwise be. Scientists believe that the atmosphere may even be escaping into space, slowly forming a thin, extended cloud around the planet. What makes WASP-193b so fascinating is that it doesn't fit neatly into existing models of planet formation. Planets this large and low in density shouldn't be able to survive for long so close to their stars. Yet here it is, stable, visible, and defying expectations. Its strange structure could help researchers better understand how heat and stellar radiation can dramatically alter a planet's atmosphere over time. In simple terms, WASP-193b is a true cosmic oddity, a gas giant that's mostly air, floating around its star like a colossal balloon. It's one of the lightest worlds ever found, proving once again that the universe is capable of creating planets far stranger than anything imagined in science fiction. Kepler 1514b, the hidden colossus. Kepler 1514b is a massive gas giant that shows the opposite extreme of the puffy planets. Instead of being light and inflated, it's dense, heavy, and truly gigantic. Located about 1,800 light-years away from Earth, this planet orbits a star very similar to our Sun and is estimated to be nearly 6 times more massive than Jupiter. Despite its enormous weight, it orbits at a comfortable distance, taking about 218 Earth days to complete one revolution. Astronomers discovered Kepler 1514b through the Kepler Space Telescope, which tracked the faint dips in starlight caused by transiting planets. What surprised scientists about this world was its combination of mass and stability. Unlike the hot Jupiters that orbit extremely close to their stars and are often bloated from heat, Kepler 1514b remains relatively compact and cool. Its atmosphere isn't expanded or unstable, which allows it to maintain a dense and heavy structure. This planet likely formed in the outer regions of its system, where temperatures were low enough for gases like hydrogen and helium to condense easily. Over millions of years, it accumulated huge amounts of material, developing a strong gravitational pull that compacted its interior. The result is a world that's far heavier than Jupiter, but not much larger in size, meaning it's incredibly dense. Kepler 1514b's orbit is also somewhat eccentric, suggesting that it may have interacted with other planets or migrated inward over time. These small orbital changes give scientists valuable clues about the dynamics and history of its planetary system. What makes Kepler 1514b especially interesting is how it contrasts with the lighter, balloon-like gas giants. It represents the other end of the spectrum, a world dominated by immense gravity and internal pressure rather than heat and expansion. Studying such planets helps astronomers understand how different conditions, distance from the star, composition, and temperature can produce drastically different planetary structures. In short, Kepler 1514b is a silent giant, massive, dense, and steady, a true heavyweight among exoplanets that quietly challenges the extremes seen elsewhere in the universe. TOI 2109b, the fastest orbiting planet. TOI 2109b is one of the most extreme worlds ever found, a superheated gas giant that races around its star faster than any known planet. Located roughly 850 light-years away in the constellation Hercules, this massive world completes a full orbit in just 16 hours, less than one Earth day. That makes it the shortest period orbit ever recorded for a giant planet. TOI 2109b is about 5 times the mass of Jupiter and nearly 1.4 times larger in radius, which means it's both heavy and bloated. The planet lies so close to its star that it is practically skimming its surface, only about 2.5 million kilometers away, which is 20 times closer than Mercury is to the Sun. Because of that proximity, its dayside temperature soars to nearly 3,200 degrees Celsius, hotter than some stars. It's classified as an ultra-hot Jupiter, a category reserved for the most intensely irradiated gas giants ever discovered. At such temperatures, molecules in the atmosphere break apart into atoms, and metals like iron and titanium exist as vapor. The night side, on the other hand, is dramatically cooler, indicating powerful winds that redistribute heat at thousands of kilometers per hour. Scientists believe the planet is tidally locked, meaning one side always faces its star, just as the Moon does with Earth. Because of its close orbit, TOI 2109b is slowly spiraling inward. Its orbit is shrinking by about 10-12 milliseconds per year, suggesting it's in the final stage of its life. Within a few million years, gravitational forces will likely rip it apart or consume it entirely. For astronomers, TOI 2109b provides a rare look into the destructive power of stellar gravity. It helps explain how close-orbiting gas giants form, evolve, and die. In many ways, this blazing world acts like a cosmic laboratory, a planet caught between existence and annihilation, racing endlessly against time itself. A super Saturn with gigantic rings. When we look at the planets in our solar system, Saturn often steals the show because of its beautiful rings. But astronomers have found a world outside our system that makes Saturn's rings look tiny in comparison. This exoplanet, discovered orbiting a distant star, has a ring system so vast that if it replaced Saturn in our skies, the rings would stretch across a space larger than the Moon's diameter as seen from Earth. The planet itself is a gas giant, already several times the mass of Jupiter. But what makes it extraordinary is its ring system, spanning tens of millions of kilometers, dwarfing anything seen before. These rings are not made of the same icy debris we see around Saturn. Instead, they may consist of a complex mixture of dust, rocky fragments, and frozen material torn apart from moons or asteroids that wandered too close. Astronomers believe the planet is young, and these colossal rings may be the raw material for future moons. In other words, we could be witnessing a solar system in the making, with moons slowly forming from a disk of debris, much like how planets formed from the protoplanetary disk around our Sun billions of years ago. The discovery of this super Saturn came from observations of how it blocked its star's light. When the planet passed in front of the star, the dip in brightness wasn't simple. It stretched out for days, showing that an immense ring system was responsible for much of the dimming. This technique, called the transit method, has allowed scientists to map out the structure of the rings even though the planet is hundreds of light years away. What fascinates astronomers most is the stability of such rings. Around Saturn, rings can last for hundreds of millions of years, but eventually, they either fall into the planet or clump together to form moons. In this case, the sheer size of the rings suggests a violent recent past, perhaps a massive collision with another planet or the shredding of a large moon. These events are cosmic catastrophes, but they leave behind structures of awe-inspiring scale. The burning ice giant. Among the strangest types of worlds discovered are those known as hot Neptunes. Imagine a planet the size of Neptune or Uranus, but instead of floating peacefully in the cold reaches of space, it orbits so close to its star that its atmosphere is boiling. One such discovery stunned astronomers. A Neptune-sized planet orbiting so tightly that a year on this world lasts less than a few days. Its surface temperatures soar to thousands of degrees, hot enough to melt metal. Yet scientists believe deep beneath its atmosphere lies a mantle of exotic ice. Not like the ice in your freezer, but ice that exists under extreme pressures, locked into crystalline forms that can survive even in blistering heat. This burning ice forms because hydrogen and oxygen are squeezed together under such immense pressure that they refuse to melt, even as the outer layers of the planet scorch under the star's radiation. To us, it sounds impossible, but physics allows such states to exist. If true, this planet would host a paradox: fire above, ice below. Astronomers study worlds like this to understand planetary migration. How did such a large planet end up so close to its star? It likely formed far away in colder regions before being pulled inward by gravitational forces or chaotic interactions with other giant planets. Its discovery shows how dynamic and violent planetary systems can be, reshaping themselves over time. For the imagination, the burning ice giant is a place of contradictions. Skies roil with blazing storms, lightning tearing through thick clouds of vaporized metals, while deep within, pressure locks away ice that will never melt. It is a world where fire and frost coexist, a reminder that the universe is never bound by our expectations. A dark world that eats light. In the depths of space lies a planet that seems to defy the very concept of reflection. Astronomers discovered a gas giant so dark that it absorbs over 99% of the starlight that touches it. To put that into perspective, this world is blacker than coal, darker than black paint, and far less reflective than even the blackest volcanic rock. Seen up close, it would look like a black void against the background of space, with only a faint red glow from its superheated atmosphere revealing its presence. Scientists believe the planet's unusual darkness is due to chemicals in its atmosphere that absorb light instead of reflecting it. Sodium, potassium, or titanium oxide gases may act like cosmic sponges, trapping radiation and giving the planet its obsidian appearance. Unlike Earth, where clouds reflect sunlight, this world has no bright features to catch the eye. Even its daytime skies are cloaked in permanent shadow. Discovered through careful measurements of starlight dimming, this world challenges our understanding of atmospheres. How could a planet become so perfectly dark? Some astronomers suggest it might have once had reflective clouds, but the extreme heat stripped them away, leaving only a bare, light-devouring atmosphere. From a poetic view, this planet feels like a cosmic omen, a world that eats light, a silent reminder that darkness can sometimes win against brilliance. To stand on such a planet, if it had a solid surface, would mean living in eternal twilight, under a star that shines but never seems to light the ground. WASP 76b, the planet where it rains iron. WASP 76b is one of the most brutal and fascinating worlds ever discovered. A giant planet where it literally rains molten iron. Located about 640 light-years away in the constellation Pisces, this world is so extreme that day and night mean the difference between vaporized metal and storms of liquid fire. This ultra-hot gas giant is nearly twice the size of Jupiter and orbits its parent star so closely that it completes a year in just 1.8 Earth days. The planet is tidally locked, meaning one side always faces the star while the other remains in permanent darkness. On the day side, temperatures soar above 2,400 degrees Celsius, hot enough to vaporize iron, titanium, and other metals straight into gas. As strong winds whip these metallic vapors around the planet, they reach the cooler night side, where temperatures drop enough for the iron to condense into droplets of molten metal. The result? A sky that rains glowing liquid iron, drifting down like fiery ash across a dark horizon. Astronomers discovered this bizarre phenomenon using the Very Large Telescope, VLT, in Chile, detecting iron vapor on one side of the planet, but none on the other. That absence confirmed the theory. The vaporized iron wasn't missing. It had condensed and fallen as rain. The atmosphere of WASP 76b is also loaded with exotic chemicals like vanadium oxide and titanium oxide, which absorb starlight and make the planet shine like a dull ember. The constant heat, extreme pressure, and violent winds make this world unimaginably hostile, a place where the air itself could slice through metal. WASP 76b is more than a fiery curiosity. It's a glimpse into nature's extremes. A world where iron falls like rain and the boundary between night and day becomes a deadly storm of molten metal. It reminds us how even the most familiar elements, like iron, can behave in alien and terrifying ways under the universe's most brutal conditions. The world of diamond rains. There are planets where storms of water fall like on Earth, but scientists have found places where storms of diamond rain may be common. On massive ice giants like Neptune and Uranus, researchers believe carbon atoms in the atmosphere are crushed under extreme pressure and heat, forming diamond crystals that fall through the skies like glittering stones. Now, with exoplanet discoveries, Worlds even larger and hotter may have this process happening on unimaginable scales. Picture an entire atmosphere where thunderclouds brew not water droplets, but diamonds, falling for thousands of kilometers until they melt back into strange oceans deep below. These conditions occur because of the abundance of carbon and hydrogen. The weight of the atmosphere forces carbon to reorganize itself into crystalline structures, just as natural diamonds form inside Earth's mantle. Laboratory experiments on Earth have recreated this effect, giving scientists confidence that these diamond worlds truly exist. If one could ever mine such a place, the riches would be beyond comprehension, but the environment itself would be utterly deadly, with pressures strong enough to crush spacecraft like paper. Still, the thought of skies filled with diamond storms captures our imagination. It transforms planets from simple orbs into glittering cosmic wonders, where nature itself becomes jeweler of the universe. HD 80606b, the planet with the wildest orbit. HD 80606b is a gas giant that takes the concept of seasonal change to an entirely new level. Located about 190 light-years away in the constellation Ursa Major, this massive planet follows one of the most eccentric orbits ever discovered. An orbit so stretched that it brings the planet from deep space to nearly skimming its star's surface every few months. The planet is roughly 4 times the mass of Jupiter and completes one orbit every 111 Earth days. But the key difference lies in its shape. Instead of a circular path, HD 80606b travels in a long, oval orbit, swinging from a distant, frozen region to a scorching close approach. When it nears its star, the planet experiences a sudden and violent heating event. Its temperature can skyrocket from 500 degrees Celsius to over 1200 degrees Celsius in just a few hours. During this fiery encounter, its atmosphere expands dramatically as gases like hydrogen and methane are blasted by stellar radiation. Then, as it retreats again into the cold, the atmosphere rapidly contracts, causing intense weather, possibly including supersonic winds, shock waves, and massive storms unlike anything seen in our solar system. Scientists believe this bizarre orbit may be the result of past gravitational interactions. HD 80606b's parent star has a companion, a second star, HD 80607, and the gravitational pull between the two could have distorted the planet's orbit over millions of years through a process called the Kozai mechanism. This world is a rare natural laboratory for studying extreme atmospheric dynamics. Observations from the Spitzer Space Telescope have even tracked how quickly the planet heats and cools, offering a real-time look at its violent transformations. HD 80606b isn't just another hot Jupiter. It's a cosmic pendulum, swinging between the freezing dark and blinding heat over and over again. Each orbit tells the story of a world caught in an endless cycle of destruction and renewal. The molten hellscape. Some planets live so close to their stars that their surfaces are literal seas of lava. One such world, slightly larger than Earth, orbits within just a few million kilometers of its star. Temperatures soar above 2,000 degrees Celsius, hot enough to keep rock melted into oceans of fire. From space, the planet glows faintly red, a smoldering ember circling its star. Scientists believe that on the day side, Rivers of molten rock flow endlessly, while the night side cools enough to form jagged fields of solidified lava. Fierce winds sweep vaporized rock around the planet, creating a bizarre rock cycle where stone evaporates, drifts as clouds, and rains back down as fiery droplets. Studying such worlds helps astronomers imagine what early Earth might have looked like during its violent youth, when it too was covered in magma oceans. These hellish planets also show how diverse rocky worlds can be. Some may resemble our Earth, while others are locked in eternal firestorms. The molten hellscape is a brutal but beautiful reminder that not all worlds are meant for life. Some exist only to burn, eternal furnaces in the sky. The water world without land. While many planets are scorched or barren, there are others that might be covered entirely by water. One such exoplanet, discovered a few years ago, appears to have a thick layer of liquid water surrounding it, with no continents or mountains to break the endless ocean. If Earth is a blue planet, this one is bluer still, a true water world. Scientists think these planets form farther from their stars, where ice-rich material gathers. As they migrate inward, the ice melts into vast oceans. But unlike Earth's oceans, these seas may be hundreds of kilometers deep, with pressures at the bottom so extreme they form exotic forms of ice unseen on our world. The implications are exciting. Such worlds might host alien life, perhaps in deep oceans warmed by geothermal vents. But they also raise questions about habitability. Without land, how would life evolve complex ecosystems? Could civilizations rise without soil, fire, or metals? For the human imagination, these worlds are hauntingly beautiful, endless horizons of water, skies mirrored by oceans that never end. They are places where entire ecosystems could exist unseen beneath the waves, alien yet strangely familiar. A rogue giant, adrift in darkness. Not all planets orbit stars. Some are rogue giants, flung from their systems by gravitational chaos and left to wander alone through interstellar space. One such rogue planet, larger than Jupiter, was discovered drifting without a sun, glowing faintly with leftover heat from its birth. It drifts endlessly in cold darkness, a lonely giant among the stars. These planets form like others, but violent encounters with massive siblings or passing stars hurl them into the void. Billions may exist, hidden in the galactic night, more numerous than the stars themselves. Despite lacking a sun, some of these giants may retain thick atmospheres and even generate heat through internal processes, making them warm enough to host subsurface oceans on potential moons. From a distance, a rogue planet would look like nothing more than a shadow, invisible unless it passed in front of a star. Up close, it would be an eerie world lit only by starlight far away, a drifting island in the endless dark. For storytellers, rogue giants are some of the most haunting discoveries, planets that know no sunrise, no sunset, only the eternal night of the galaxy. Gliese 436b, the burning ice planet. Gliese 436b is one of the strangest planets ever discovered, a world made of burning ice. Located just 33 light-years away in the constellation Leo, this Neptune-sized planet completely defies logic. Despite being covered in water, it burns at over 700 degrees Celsius, hot enough to melt lead. Yet somehow, that water doesn't evaporate. The reason lies in the planet's extreme pressure and gravity. Gliese 436b is about 23 times the mass of Earth, with a dense core that traps water molecules deep inside. Under such crushing pressure, water behaves in exotic forms, turning into a solid even at extreme temperatures. This hot ice, or Ice 7, is unlike anything found naturally on Earth. It stays frozen not because it's cold, but because gravity compresses it into stability. Orbiting a red dwarf star just 4 million kilometers away, Gliese 436b completes a year in only 2.6 Earth days. Its orbit is surprisingly tilted and slightly oval, suggesting it may have been disturbed by another unseen planet long ago. That irregular orbit creates powerful tidal forces that heat the planet's interior, keeping it molten and active. Astronomers believe Gliese 436b once had a thick hydrogen atmosphere, much like Neptune, but stellar radiation has slowly stripped much of it away. What remains is a hot, compact world where solid ice coexists with blazing heat. A direct contradiction to everything we know about physics and climate. The existence of Gliese 436b challenges our understanding of planetary chemistry. It proves that under the right pressure, even something as simple as water can behave in alien ways. This world is both a paradox and a warning, showing that nature doesn't follow our rules, and the universe still holds surprises far beyond our imagination. The vastness of the universe reminds us of just how small we are, yet how boundless our curiosity can become. Across the endless ocean of stars, worlds of unimaginable scale and power continue to orbit in silence, shaping the very fabric of their systems. These colossal planets are not just scientific curiosities. They are milestones in our attempt to understand the grand design of creation itself. Every one of them whispers a fragment of a larger story, one that connects us to the origins of stars, galaxies, and perhaps even life. And yet, what we know today is only the beginning. Hidden in the shadows of distant galaxies, countless more worlds are waiting to be found, stranger and greater than we can conceive. Our search is far from over. It has only just begun. So as you look up into the night sky, remember, beyond every twinkling star lies the possibility of another giant, another wonder, another piece of the infinite mystery.